So the last thing I want to talk about is I want to summarize everything that we've done about confidence intervals, and we have time to work on one, maybe two problems. Okay. So here's the summary. Confidence intervals. So confidence interval summary, if you're doing a confidence interval for a mean mu where you know sigma, the formula is x bar plus or minus z times sigma x bar. If you don't know sigma, it's the t distribution, and your formula looks like x bar plus or minus t times sx bar. What about a confidence interval for a proportion p? The formula is p hat plus or minus z times sigma p hat. Okay. Now, writing it out like this, it's almost obvious. The pattern should become very clear and obvious as to what's going on with the formula for a confidence interval. The only thing that remains to know is what's the formula for sigma x bar, what's the formula for sigma p hat, and that's a separate thing that you guys know as well. I like writing out like this. The textbook likes to write the formula with everything all mushed in there. So for example, p hat plus or minus z sub alpha over 2 times the square root of p hat 1 minus p hat over n, blah, blah, the square root, blah, blah, all that stuff. So I don't like writing it like that because it obscures, as far as I'm concerned, what's really going on. What's really going on is that the basic formula for confidence interval is always the same thing, with these adjustments that you know. Sigma x bar versus sigma p hat. So that's one thing. Okay, something really important. When you're working on a confidence interval problem, particularly if it's a word problem, start off your problem thinking about, is this a problem about means or is it about proportions? And it's not always immediately obvious. For example, in the question it might say, you might have to calculate the proportion. For example, it might say 67 out of 120 people said yes. Or we interviewed 120 people and 67 said yes. So what is that problem? Is this problem about means or proportions? It's about proportions, and how do you find your p hat? Right, it would be 67 divided by 120. I have to say this is definitely one of the three most common mistakes that I see, is that people don't, when they see 67 out of 120, they don't recognize that as a proportion and as part of a proportion problem. And they simply say, oh, I guess my x bar is 67. And of course, once you do that, I'll bond on the comment you made before, well, I don't have a sigma. Well, that becomes a problem when you try to calculate the formula, sigma divided by the square root of n. And then as someone grading the work, I see all these kinds of problems from people not recognizing that this is really a proportion problem. So that's a major thing to keep in mind as you're doing this. And then finally, we saw sometimes we're told we're given a constraint for what the margin of error E should be, and then go ahead and find n, and then we have formulas for that. On the one side in case we're dealing with means, on the other side in case we're dealing with proportions. Okay. So that's this whole topic boiled into half a page. All right. So let's look at a problem and do it from scratch. Okay. Are the people in support of stricter gun control laws? Out of 400 people surveyed, 296 say yes. So what is your 96% confidence interval? What's your point estimate? What's your margin of error, etc.? Okay. So how do we start this? How do we start this question? What do we say? Okay, so what's the formula going to be? There you go. So in particular, Elizabeth is saying that this problem is about a proportion. Okay, so that's one important thing to recognize. Okay, so here's our formula. So the formula is going to guide our work. So what do we need to figure out? Okay, so even easier. First I'm going to say let's find p hat. Then yes, we should do that. Okay. So a couple things. So first of all, what's p hat? How do we find p hat? No. What does p hat mean in words? Well, it's similar to x bar, but what does p hat mean in words? P hat. P hat represents the what? It's the proportion of the sample. Whoever said that? Yes. So p hat is the proportion from the sample. So what is the proportion from the sample in numbers? There you go. So if you know what these things are, it helps do the problem. P hat is the proportion of the sample. What's the proportion of the sample? 296 out of 400, which is 0.74. Next thing we can find, Albana? Sigma p hat, exactly. So how do we find sigma p hat? So p hat, so 0.74 times 1 minus 0.74 all over what? Divided by what? Divided by n 400. So let's work that out. .0219. Next. Yes. Is it normal? And how do we see if it's normal? Is that at least 10? So we got 400, 0.74 because we're using p hat, and then 1 minus 0.74. Is that at least 10? It's 76 something or other, certainly bigger than 10. So it's normal. Now that we know it's normal, what can we do? Draw a picture. And so what goes on the picture? Zero in the middle for Z, and what else? P hat values, okay, and what else? I'm sorry? Where's 0.74 go? Underneath the zero, middle for p hat. Okay, and what else? And so where does 0.96 go? The middle for, it's the middle area, right? Okay. And so now we can start to figure stuff out. So once we know that, what else can we fill in? Point what? 0.02 in each tail. Because it's 0.04 divided by 2. Okay. And then once we have that, now what do we find? Z-score. So, area to the left is 0.02. Knock it out. There's our Z-score. 2.0537. And now we have everything we need. So the confidence interval is numbers 0.74 plus or minus z. Well, z-score is 2.0537 times sigma p hat, which is 0.0219. That all works out to 0.74 plus or minus 0.0450, and that works out to 0.6950, 0.7850. And we just state our conclusion. So we're 96% confident that we're between, and again, these are proportions, so you don't have to, but I like to state it in common language. So 0.695 is really 69.5%. So it's between 69.5% and 78.5% want stricter gun control laws. And also, what is the point estimate? Yeah, it's 0.74. That's our best guess. And what is the margin of error? Nope. Yeah. It's 0.0450. It's the whole plus minus part. Now again, remember, we're talking about proportions, so that 74 is really the same as saying 74%, and that margin of error is the same as saying 4.5%. And then, just to run through one of these problems, which actually goes quite quickly. Suppose you want E to be 0.05 with 99% confidence, and we'll take P hat to be 0.5 again. How big does your sample need to be? How do you do this problem? Yep, just the formula. So N equals, and you'll get practice using it, it's Z squared times P hat times 1 minus P hat over E squared. Okay. So, let's see. What is it that we know? What do we need to figure out? So P hat we know is 0.5. Then we've got 1 minus 0.5. And we know E is 0.05. What's the only thing we squared? What's the only thing we need to figure out? Z. And how do we figure out the Z score? What's going to help us figure out the Z score? Yes. So 99%, and what should I do with that? Draw a picture. So here you've got the picture. And what do I put on the picture? .99 is the middle area. And once we know that, what else do we know? Right. It's .01 split in half, so it's .005 in each tail. So go in here, area to the left is .005, and there's your z-score, 2.5758. Now that we've got our z-score, we can just plug that in to the formula where we need it. And if you work this out, you get 664. Any questions? Okay.